Hello everyone. Today I'm going to demonstrate how to connect to an AWS IoT server using our MQTT server object with the cloud service option set to normal. To begin, let's open an instance of EasyBuilder Pro. And during this demonstration I'm going to use a CMT 3072XH, but the MQTT server object can be used on any HMI model except the IP series. However, it is important to note that certain features discussed within this tutorial are only available on CMT and CMTX HMIs. With my application open, I'll close the system parameters and navigate to the IIoT/Energy tab. Within this tab, we'll find the MQTT server object. To connect to an AWS IoT server, we'll need to enable MQTT and define the communication parameters. Much of this information can be found within Amazon's AWS documentation. At the top, we'll leave the cloud service option set to normal and define the protocol version as 3.1.1. I'd like to note that the normal cloud service option is also compatible with IBM Cloud, Microsoft Azure, and Alien by Alibaba. Rather than use an IP, let's enable Use Domain Name and enter the IoT endpoint listed within our AWS account. To find the endpoint, select the Settings option while logged into AWS, and on the following page, copy the device data endpoint. The port number listed within AWS documentation is 8883. This port number should be used by MQTT devices that will both publish and subscribe to the broker. The required authentication is an X.509 client certificate, which we will retrieve and use within the TLS/SSL tab momentarily. The client ID should be a unique identity assigned to the HMI. Each device that connects to the broker will need a unique client ID and certificate. By using the random syntax, %2, the client ID will be populated by a random string of alphanumeric data. This does not guarantee that the ID is unique, however, it is quite likely. Now, there are some additional parameters here that we won't need to modify during this demonstration. This includes authentication, which will allow you to enter a username and password when connecting to an MQTT broker. Keep alive time, which specifies how long the server will wait before identifying the HMI as disconnected. The timestamp can be sourced from UTC time by referencing the HMI's time zone settings or from the HMI's local time. Clear message buffer when disconnecting gracefully will clear the MQTT message buffer. The buffer can hold up to 10,000 messages. Messages that are not sent will be stored within the buffer, and a buffer usage address can be configured within the Address tab. And close inactive MQTT connection automatically will disconnect the HMI from the server while it is inactive for a given period. With that finished, I'll select the Address tab and configure a status address. The status address will set the status of the HMI's connection to the MQTT server within the address shown, and the next consecutive address will display any error codes that occur during operation. Now we can also configure a control address, which will allow us to change various parameters during runtime, but this will not be necessary within our application. Within the TLS/SSL tab, we'll need to add the X.509 certificates and the CA file from AWS documentation. If you're not familiar with TLS or SSL, these are just encryption standards that AWS and many other companies use to protect client data during transport. To generate these certificates, log into your AWS account, and within the AWS IoT dashboard, select the Security tab and click Policies. A policy in this instance will determine what our MQTT client or thing is allowed to do. A single policy may be applied to many different devices. On the following page, select Create Policy and give your policy a name. I'll name mine Wintech HMI. I'll configure my policy to allow all AWS IoT actions. You may use the settings shown within this tutorial or define your own. Click the Create button on the lower right corner when finished. Now let's create a thing by selecting Things within the All Devices tab. Per AWS documentation, a thing is a digital representation of a physical device, like our HMI. On this page, select Create Things in the top right corner. And on the following page, I'll select Create Single Thing because I only have one device. I'll name my thing CMT3072XH. But you should use a unique name for each thing that you add to your AWS IoT account. Next, we'll choose how we register a certificate for our device. I'll leave Auto-Generate a new certificate selected. We'll attach our policy and then click Create Thing. Within the following pop-up, we'll need to download the device certificate, public and private key files, as well as the Amazon root CA1 file. When finished, click Done. Use the Import button within EasyBuilder Pro to import the CA file, the device certificate may download as a standard text file, in which case we'll need to remove the .txt extension. We'll import this file under Client Verification. And as stated, we'll need to import the private key as well. At the top, you'll notice a TLS version drop-down list. Currently, AWS IoT uses TLS version 1.2, so we can leave this at the default setting. Within the System Topic tab, you can enable certain specialized topics that the HMI will publish during certain conditions. For example, when Topic List is selected, the HMI will publish a list of available topics to the server upon connection. For more information about system topics, please see Chapter 42 of the EasyBuilder Pro User Manual. To publish a topic, we'll select New within the Publish tab and define our parameters. First, I'll give our topic a name. AWS topics support a maximum of 8 layers, so if I define our topic as example/1, this counts as 2 layers. And if I define our topic as example/data/1, this counts as 3 layers, indicated by the /. During this demonstration, I'll configure the topic name to HMI/data. There are a few different triggers that can be used when publishing data. We can have the HMI published to the broker when the value changes. We can also publish on a preset time interval, or even publish when a Boolean trigger changes states or when an alarm is triggered within our project. During this demonstration, we'll send messages on a preset time interval. I don't need to configure a compression type, but you may do so if required by your application. What I will modify is the QoS. According to AWS documentation, AWS IoT only supports QoS 0 and QoS 1. The QoS level indicates the minimum number of times a message is sent, meaning QoS 1 ensures that the message is sent at least one time. We'll use this QoS level within our demonstration. The Retain Message option will allow the MQTT server to retain the last message published by the HMI. There are 3 different ways to format the content of our message. When raw data is selected, our data will be published as an array of bytes. JSON Simple will automatically add the values you intend to publish and any option selected below into a message using JSON format. And JSON Advanced will allow you to customize and preview the structure of your JSON message within the Address tab. During this demonstration, we'll create a topic using both JSON Simple and JSON Advanced, starting with our simplified version first. The options below JSON Simple will allow you to add a timestamp to the message, or make each address a property of an object titled D. This feature was created to prevent the timestamp from appearing as an address name. I'll leave both options selected, and we'll add an address to monitor within the Address tab. To do this, I'll select New and we'll monitor one of the HMI's internal bits, LB0. We can call this value Data. With that finished, I'll click OK and we'll define a new message to publish. I'll call this topic HMI/data/advanced, and we'll define the same settings as before, except this time we'll use JSON Advanced. Within the Address tab, we can use the Preview button on the lower right-hand corner to preview the format of our message. If the application requires a specific format and you have access to a text-based copy of this format, or if you've already defined this format within another topic, you can paste this into the Address tab using the Template button. For now, let's delete the current values and add some by hand. Let's start by adding a new object called bits and another new object under payload called strings. As a property of the bits object, I'm going to add a new value called bit1, which will read the address LB1. And as a property of the strings object, I'm going to add a new value called string1, which will read 10 words of string data starting from address LW2. And with that finished, I'll preview my message to make sure that I am satisfied with the format, and then click OK. Now, let's subscribe to an existing topic. To do this, we'll select the Topic Subscriber tab and click New. Since this is the only device that I have that will publish to the broker, I'll subscribe to one of the topics that we've already defined, although typically this topic will be published by another device. This is also a great time to point out that it is possible to define a dynamic topic name by using the %dynamic syntax. This will allow the MQTT object to reference the topic name from an external register, which in turn will allow you to modify the topic name during runtime. For the most part, we'll use the same settings as before. However, you'll notice a new parameter called Operation Mode. This will allow us to determine how the HMI handles incoming data. We can either configure the MQTT object to process changes immediately without intervention, or we can manage messages manually using a control address. We'll leave this set to process immediately during this demonstration. Now, let's select the Address tab and configure the values that this object will subscribe to. Like the topic, it's important that we use the correct name and case of the value that we want to subscribe to. Within the name entry box, I'll type data. As before, there are a few additional parameters that we can select. When required for incoming messages is selected, the MQTT object will reject messages that don't include this value, meaning that if the message received has other values that we would like to read, but this value is not present, the other values will not be used to update the addresses specified within the MQTT object's address tab. While Remove JSON Array Bracket is selected, the MQTT object will only process the message and allocate data to the specified registers if the format of the published message also has the array brackets removed. And accept null ensures that the HMI can process the message in the event that the message contains a null value. With that finished, I'll create some objects that correspond to the addresses defined within our topics, as well as the status and error address used by the MQTT object. To begin, I'll create a toggle switch addressed to LB0. This address corresponds with the data value within the HMI/data topic that the HMI will publish. And since we're subscribing to this topic as well, let's create a bit lamp addressed to LB2. This address is used within the HMI/data topic subscription. Let's create a numeric object for the MQTT status. This should be addressed to LW0. And I'll create a numeric object for the MQTT error register at LW1 as well. Now, I'll create a few additional objects, select the Project tab, and run an offline simulation. With my simulation running, I'll use the toggle switch to set LB0 on. And since the HMI is subscribing to this topic, this value will be set with an LB2 as well. If you have a CMT series HMI, you can even use the CMT diagnoser to monitor the messages sent and received in real time. To do this, right-click on the simulation and select Diagnoser. And within the CMT diagnoser, select the MQTT tab. Here you can check the status of the application's connection to the server by selecting the Server tab. Although to view a specific topic, select the Address tab, ensure that the topic is selected, then select the Published tab to view topics that are being published by the HMI, or select the Subscribed tab to view topics that the HMI is subscribing to. Here we can view each message sent or received at the specified timestamp. It's also possible to view messages using the AWS IoT MQTT test client by either specifying the topic name or by using a wildcard character. For more information about the AWS IoT MQTT test client, please read Amazon's AWS IoT documentation. If you found this tutorial helpful and would like to see more, head on over to our channel to check out the latest technical tutorials. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.